Hi students. So today we'll study one more new chapter, that is thermodynamics. So what is this thermodynamics now? Right? So do you see anywhere we are using the thermodynamics in our day-to-day life? If yes, please comment me. Therefore pause the video. See, we are using in our day-to-day life no this thermodynamics no where in our vehicles. So how the vehicles will move? So we'll fill the petrol. So then so it will move. But when you are filling the petrol, so what is happening, right? That petrol now. So that petrol it will be utilized. So it will be inside the engine. Therefore it will be burnt. Therefore that burning, right? Therefore converted into like a heat. That heat energy is converted into like a mechanical energy. That means it is making our vehicle to move forward now. So thermodynamics means what? Thermodynamics. Thermo means what? It is nothing but a heat. Thermo means heat. So dynamics, that means it is mechanical energy. Therefore, heat energy is converted into like mechanical energy. Mechanical energy. Clear? So thermodynamics means what? Converting the heat energy to mechanical energy. Lot of this all ships, all this are no. Therefore, this works under the based on the thermodynamics only. Right? Now, how we will convert it? How we will convert the heat energy into mechanical energy? How we will convert it now? So first of all, to convert this one now, we require one system. One system. Therefore, what is the system here now? So here we are going to take it as like a one cylinder no. Therefore, this is one cylinder no, and we are going to take it as like a one mobile piston no. Therefore, this is one piston. This is mobile piston onto this. So this piston inside this one no, there is a gas is present here now. Okay, this is one system here now. This is converting our heat energy to the mechanical energy. How it will convert it now? Let us see. So our generally, therefore this is one gas, right? This is a gas. So for this gas no, we are giving certain amount of heat. We are giving the heat energy to the system now. So what will happen now? This system, it will take the heat energy. So that gas, it will get heated up, its temperature will increase. So when temperature is increased, what will happen now? Therefore it is gaining internal energy. And some amount of energy, it will be converted into like a work. That means not only gaining the internal energy, so it is also collides with the piston onto this. This it will make the piston to move toward this side. That means this piston is moved from here to here by moving, therefore it is doing certain amount of distance. This distance, this work done, only we can call it as like a mechanical energy. How it will be done now? When this piston is moved, so for this one, there is a one shaft rod will be there. So there will be a one gear system will be there. So here also there is a one wheel will be there. Here also some gear system it will be connected here now. So therefore, when the piston is moving onto this one, no, so therefore this rod it is going this right our gear it will be rotated no. So that rotation it will be given to the vehicles onto this. Here's this is a simple basic no. Later on lot of mechanism will be there. So this is a simple one no. So where heat energy will be converted into like a mechanical energy. Here this piston is moved from here to here. It is done certain amount of work done. Clear? So now, so we are supplying the heat energy. So therefore, here this heat energy is utilized by the gas and it is utilizing to increase in the internal energy, and also remaining other energy it will be utilized to do the certain amount of work. So by converting these relations onto this, so we want to have the relations no, that was given by in the first law of thermodynamics now. What is this first law of thermodynamics no? It is based on law of conservation of energy. It is based on law of conservation of energy. Clear? Based on the law of conservation of energy, right? So how much energy we are giving now? Delta Q, change in internal energy, change in heat energy. Delta Q we are giving no. It is utilizing the increase in internal energy plus, and it is also doing some work now. Therefore delta W, This is our first law of thermodynamics. Delta Q is equals to delta U plus delta W. To use this one now, to use this, so we have to follow certain amount of rules for this, right? So delta Q, so like sign conventions, no? If you are heating means what? We are supplying the heat energy. So at that point, delta Q taken as positive, right? So suppose if you are cooling, that means we are extracting the heat energy. So delta Q taken as negative here. Clear? So when you are heating, so delta Q is positive. When you are cooling, delta Q is negative. So what about the internal energy here now? Therefore, here delta U. So therefore, here if the temperature of this one now, temperature of this gas is increased, so that means it is heated up. So when temperature is increased, so delta U is taken as positive. If temperature is decreased, that means cooling, therefore delta U is negative. Clear? So therefore what about delta W now? Delta W, so therefore work done. Therefore, if is work done by the gas, that means work done by gas. That means what? It is expands. When it is expands, delta W is positive, right? So if it is work done on the gas, work done on the gas, that means it is compressing. When compressing, no? So delta W is negative. Volume is decreasing. So volume is decreasing, delta W is negative. So volume is increasing. So delta W is positive. So these are the things, no, you need to remember, minimum thing for the first law of thermodynamics onto this. Clear? So first law of thermodynamics, it is nothing but a basic law of conservation of energy. So if you want to apply, you should know all the formulas related to delta Q, delta U, delta W now, right? So let us study. So one by one onto this one now. So about heat energy, right? What is heat energy here now? We are supplying the heat. So for which one we are supplying now? We are supplying for the gases. So how much amount of heat energy we have to supply now? So both the ways you have to supply. So delta Q at V, therefore N CV into delta T or delta Q, it will be at a constant pressure. It is nothing but a NCP into delta T. Here one interesting result you are going to observe this point now, very important point here in this point now. What is this? Delta Q, that means heat energy supplied at constant volume, that is nothing but a NCV delta T. Volume is constant means, so volume is not increasing, volume is not decreasing. So when volume is constant, therefore it is indicate that amount of work done, it will be the zero. Clear? Because it is supplying the heat energy. So by making the volume constant means, so work done is zero. So when work done is zero, what will be the first law of thermodynamics? No, delta Q is equals to delta U plus delta W. Delta W is zero. So therefore this is nothing but a delta Q at constant volume is utilizing this energy to convert only internal energy. If we are supplying the heat energy at constant volume, the total heat energy is utilized by the gas to increase its internal energy only. Here, so internal energy formula is also can be written as, therefore NCV into delta T. Clear? So in this NCV into delta T is also nothing but a internal energy formula. Here, so delta Q if you are supplying here, no, so there is no work done is not zero here, no. So therefore delta Q at constant pressure is nothing but a delta U plus delta W. So constant pressure means P into del V. You can rewrite it as. Clear? So this heat energy is a path function. It is a path function now. So that means, so the amount of heat energy is supplied, it depends upon the path of a PV graph onto this one now, right? So it's a path function, not a point function onto this. Clear? So these all are the information about heat energy supplied to the system. Next internal energy, very important formulas. internal energy. So we already studied what is internal energy of an ideal gas. For an ideal gas, we assume that potential energy between the molecules is zero. So internal energy is nothing but a U is equals to, we already studied in kinetic theory of gases, that is nothing but a F by 2 nRT. So U is equals to F by 2 nKT. This is the internal energy formula. Now we want to calculate change in internal energy. What is the change in internal energy? Delta U is nothing but a F by 2 nR into delta T. Clear? So delta U is nothing but a F by 2 nk into delta T. Clear? So this is your change in internal energy formula. Clear? Now also internal energy, just now we written what is the formula here, no? Delta U is nothing but a NCV into delta T. So what is this N into CV? CV is nothing but a R by gamma minus 1 into delta T. Clear? R you can write down NR into T final minus T initial by gamma minus 1. We know that PV is equals to, therefore nRT. So therefore we can write down nRT final means what you can write down? So P final V final minus P initial V initial by gamma minus 1. So this it will be your internal energy formula. Clear? Internal energy formula this is, and also these all are internal energy formulas. So this internal energy depends upon initial point and final point, does not depend upon the path, no. This is a nothing but a point function. So that is nothing but a path independent. Path independent. That means how we are taking from one state to another state, or one state of the gas to the another state of the gas, no. So it does not depend upon how it is followed. It depends upon initial and final points now. Here one important point mostly in the examination they are asking, no. So what is this one, no? Let us do. Here this is P V graph, no. We will take it as from A. So therefore we are taking to the point of B. So therefore again we are returning from, so B to again, so in a different path, no. Therefore to A. So therefore we are going from here to here, here to here. It's nothing but one complete cyclic path, no. So what will be the change in internal energy? Change in internal energy, initial position and final position in final value minus initial value, both are same only. Change in internal energy will be 0. Right? So for a one completely closed, cyclic path, no, change in internal energy is 0, but internal energy is not 0. Keep in mind, here it's some amount of internal energy will be present, but that internal energy is not 0, but change in internal energy will be 0 onto this. This point is very, very important point, no. Most of the times in the examination they are asked. Clear? Now we will go for amount of work done here, no. Therefore work done. Work done. So what is the work done formula here now? We know, we studied. So work done, it will be equal to integral F dx. But pressure is equals to force by area. Force is equals to pressure into area. So you can rewrite it as pressure into area into dx. In our system, so therefore we do not have change in area onto this, no, only change in displacement will be there. So we can write down P into dV. Therefore V1 to, so V2. Clear? So integral P dV is nothing but a, therefore area under PV graph along volume axis. So this is your work done formula now, right? So work done on the gas, no, or by the gas, no, that can be calculated as integral P dV. So that is nothing but a equal to area under PV graph along the volume axis only. So let us do one by one situation, no. Let us do one simple question, no. Suppose here this is volume This is your pressure. So suppose if I am taking from here to A to B here, no, this is P, therefore it is changed its volume, it is V to suppose 5V. What is the work done now? So work done here, first of all by seeing this graph now, this PV graph now, so you should understand what is happening now. From A to B, this is making pressure is constant, that is nothing but a isobaric process. It is expanding now, so see here from volume V to so 5V, therefore it is nothing but a expansion. When an expansion is there, so work done is positive. Keep in mind. How to calculate the work done now? Therefore, here you should calculate the area under this one. No? What is the area? This volume is nothing. 5V minus V is nothing but a 4V. So, this is nothing but a pressure P. So, length into breadth. No? So, therefore, work done is nothing but a work. It will be equal to P into, therefore, 4V. That is nothing but a 4 PV will be your answer. Clear? Similarly, so suppose here one more question, no? Suppose here this is P, this is V is there. Here we are taking from here to here. Therefore, this is A to B. Therefore, it will be 5 ATM. So, this is it is 10 cc. Now, what will be the work done in this situation? No? So, work done, what you have to do? You have to calculate area under this one. No? What is the area under this? Now, this area under this. Work done. So, this distance is how much? No? 10 cc. This distance is how much? No? 5 atm. Therefore, it is 10 cc. Cubic centimeter means how much? No? 10 to the power of minus 6 meters. Meter cube into 5 atmospheric pressure. 5 into 1.01 into 10 to the power of 5. So, you can write down 10 to the power of 5 minus 5 plus 5 can cancel. So, 5.05 joules of work is done in this one. No? So, you can calculate it now. Clear? But here what happened now? From 10 cc to 0 cc, therefore no. So, therefore, it is undergoing like a compression onto this. Compression means what will happen now? Work done is negative. Therefore, keep the negative here now. Clear? Right? Or you have to take it as like a final volume minus initial volume. So, therefore, final volume is 0, initial volume is minus. So, like that also you can calculate it now. Clear? So, now, so we'll go for one more concept here now. So, let us see here. Therefore, this is pressure. So, this is volume. Therefore, here the graph is like this. This is now. So, this is A, 2. Therefore, this is B. So, what is given now? Therefore, it will be, so 5, right? Suppose here it will be 2 liters. Here it will be given as like a 7 liter. Clear? So, this is about 2 atm. So, this is about 5 atm atmospheric pressure. Right? Right? So, now we want to calculate the work done from A to B. A to B, what happened now? From A to B, so here volume is expanded onto this one, no? Work done is positive. So, therefore, here you have to calculate the work done onto this. You have to calculate the area. Which area? Most of the students know what they will do. They will calculate this area. So, please observe this one now. Here it is a pressure is there. Here it is a volume is there. Along the volume axis, should not find this volume, this area, should find this area. Clear? Area will get it as like a work done. How this area looks like now? So, this is one parallel side, these two are parallel sides now. And this is your perpendicular distance, like a trapezium is there. So, work done is nothing but area, therefore 1 by 2 A plus B into height. This is area of the trapezium. So, what is the area now? Therefore, 1 by 2. A is how much now? Sum of the parallel sides. A and B are parallel sides. H is nothing but a perpendicular distance between the parallel sides. So, this is this value 2 atm, 2 plus. So, these two are parallel sides. Observe this one now, right? So, this value, right, is one more parallel side. That means how much now? 5 atm. Atm means how much now? 1.01 into 10 to the power of 5 Pascal. Height is how much now? That means perpendicular distance between that, no? So these two are nothing but 7 minus 2, that is nothing but 5 liter. 5 liter, so is equals to how many meter cube now? Therefore 1 meter cube is equals to 1000 liters. So 1 liter is equals to 10 to the power of minus 3. So 10 to the power of minus 3 meter cube. This many joules. Always use the SI unit now. So this is 7 into 5 divided by 2 into, so therefore here it will be 10 to the power of 1.01 into 10 to the power of 2. Clear? So therefore here 35 into 101 divided by 2. So how much will get it now? You can multiply it, no? Therefore 100. So therefore here 3500. So therefore 100, no? 3. So plus 35. Therefore 3535 divided by 2. Clear? How much it will be? So therefore 1. So 7, 14, 12. 12 means 6. So 7, 14.5. Therefore 177.5 joules now. Clear? Now we will do one more type of questions now. Therefore see here one complete cyclic process now. Therefore one cyclic path. So let us see here pressure into volume. So we can take it as like A. So one cyclic path now. Therefore it is A to B. So this one now. A to B to C into D. So let us take this as V. So this is V. Therefore this is nothing but a 3V. So this is nothing but a P. So this is nothing but a 4P. Suppose easy calculation now. So we want to calculate first of all work done from A to B. So work done from A to B. A to B, observe this one, only A to B. So he is asking what is the work done from A to B. A to B is what? It is nothing but a expansion. See, volume to V to 3V. Therefore expansion, work done is positive. Clear? So area is what? From here to here, till here you have to calculate the work done now. I mean area. Clear? So therefore till here now, full of this one, full total area of this one. What is the area? This total height it will be 4P. So therefore, this total height it will be equal to 4P here. No, this is totally how much now? It will be 4P. So this total V is how much now? Therefore it is 2V. Clear? So therefore it will be nothing but a plus. So 4P into 2V, therefore plus 8PV will be the work done onto this one. Clear? From A to B, positive. Clear? So now we'll go for another concept. No? So here now work done from B to C. Right? B to C, what is the work done now? Here, therefore, there is a volume is 3V only. From here 3V, 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 3V. There is no change in the volume. So therefore work done it will be the 0. There is no change in volume. Clear? But what happens now? What you can understand from B to C, what is happening now? Pressure is dropping from where to where? So 4P to P. But work is not done. How the pressure will drop now? Work is not done. In this one, no, work is not there. But pressure is dropping now. So pressure is dropping means what will happen now? So compulsory energy has to be taken out. Therefore, in this case, therefore from here to here, energy is flown out. Certain amount of energy will be taken out. That means cooling process is taken place now. Clear? Like this, you should able to analysis now the each and every step now. Now we want to calculate what is the work done from C to D. What is the work done from C to D? So C to D, see here 3V to 2V. That means undergoing compression now. Compression means work done is negative. So therefore, what is the work done now from here to here? This area only you have to take it onto this. So what is this area? This area is nothing but a P. So this is nothing but a 2V. Therefore, this is minus. So P into 2V. Therefore, 2PV will be the work done from moving from C to D. Clear? Right. Now, so work done from D to A. So work done from D to A. Therefore, here also, therefore volume is not changing onto this one. No, only pressure is increasing. No, so volume is not changing. Therefore, work done is 0. But work done is 0, but pressure is increasing means compulsory there is a supply of heat energy to this one. Clear? So you can write down the first of thermodynamics, then you can able to calculate it now. Clear? So now we want to calculate what is the work done for complete cycle process now. For complete full cycle onto this, work done from A, B, C, D to A. So total of this, no, you need to add up all this. What you can write it now? Plus 8 PV 0 minus this one, no, therefore plus 6 PV will be this one now. So try to calculate the area under this only this loop now. So this loop, what you will get it now? It will be equal to area under, so A, B, C, D, A loop. Therefore, so if you are calculating A, B, C, D, see what is this now? This distance is 2V. So this distance is nothing but 3P. 3P into 2V, therefore it is 6PV. That's all. So here what is happening now? Here completely, here how it is there now? It is a like a cyclic path onto this one now. So this is clockwise onto this one now. Therefore, if it is a clockwise, if a clockwise cyclic path now, work done is positive. If it is anti-clockwise, if it is an anti-clockwise, work done is negative. Clear? Clear? But don't stick on to this one, no, always. So sometimes we'll see some changes will be there if you're changing this axis onto this one. At that time, slightly different. We'll do one type of question on that also. Can you tell me what will be the internal energy, change in internal energy in this one now? Change in internal energy, so will be for complete cycle, it will be 0 on this. In this way, you can calculate the work done. So in a different scenarios onto this. Clear? Now these are the basics related to the thermodynamics. No, so we'll do one more part of this, like a different process. So like isothermal process, adiabatic process, isobaric process, isochoric process. These are all the process in the next part, and then afterwards we'll do numerical questions related to this thermodynamics now, right? So thank you. Please subscribe to my channel now.